Since Tamara got things started on the reinforcement topic, in our next two sessions, we're going to focus on the improvements of automated reinforcement within Allplan. Therefore, I'd like to welcome my next guest, Daniel Bacon. Daniel is technical director and co-founder of the German company GBC Engineers. He also belongs to the pool of beta testers and will share with us his early experiences within Allplan 2025. Welcome, Daniel.
Hi, Tim. Thanks for inviting me, and a warm welcome from my side to all event participants and to the Allplan team.
Yeah, Daniel, thank you to have found time to participate in today's event. Before we get going, can you tell us a bit more about yourself and your company?
Yeah, sure, Tim. You introduced me already. Yeah, I'm a structural engineer, technical director, and co-founder of GBC Engineers. GBC Engineers is a structural design consultant with specialization on industrial structures. If I would have to pinpoint some of the main fields I focus on, it's technical quality within our organization, the technical oversight of the projects, and also the training and development of our employees with our in-house training system. That's about it, yeah.
Your job actually sounds very versatile. What makes you passionate about your profession?
Well, I really like the creativity and the impact we can make as structural engineers. When I started to study structural engineering, I always thought the architects were the creative ones, but over time I've discovered that there's a lot of creativity which lies in the field of structural engineering. We help architects execute their ideas, and the way we do that can be very different. So there are good and poor structural designs, and that can really greatly impact your project in terms of budget, construction speed, buildability, but also new topics such as carbon footprint. I also enjoy working in a team, and of course, in our job, our work is visible to many people, so I think that's a very special thing which is also satisfying in our job.
As a structural engineer, the quality of your work also depends on the right tools and software. For how long have you been using Allplan?
We've been using Allplan since around 6 to 7 years now. It's really been a great tool and reliable tool helping us to deliver our services to our customers and growing our business, of course. And we are also very happy with the support and the valuable exchange we've had with Allplan over the years. And it's always great to see how they kind of take over the ideas that we've pitched to them and implement some of the things into this software.
Of course, you have been involved in multiple construction projects over all those years. What kind of projects are you typically using Allplan for?
Well, we use Allplan for a variety of scenarios. So it can range from buildings over tunnels, bridges, retaining walls, factories, or other industrial facilities. I would say over the last 4 years, we've mainly focused on industrial structures, and we've especially developed a strong competency in the design of data centers. So in the last 2.5 years, we've designed around 300,000 square meters gross floor area of data centers. So that's probably around 300 megawatts. And there's still a strong demand. As you see, the demand for cloud computing and AI is still growing.
And how does Allplan help you with these projects? Why do you like Allplan?
Well, what I really like about Allplan is, first of all, it's a really strong 3D modeling tool and a BIM software, but it also has the capability of delivering really excellent drawings. Yeah, and that's what we still need on site. And it's a tool that can perform all design stages. So you can do a concept in Allplan, but you can also deliver precast shop drawings on scale. Yeah, especially with the data structure that we have in Allplan with the drawing files, we're able to deliver a high level of detail, a very large project without having significant performance problems like you may have with other products. Yeah? And we are especially happy that you have integrated since 2023 the precast functionality with the automated drawings. That was really a game changer for us.
Yeah, as I mentioned before, you had the chance to be part of our beta tester group for Allplan 2025. What is your favorite feature in the latest version of Allplan?
Well, as a beta tester, I've had the I've had the chance to review the automated reinforcement, and what I can say is I really like that the Allplan team is focusing on getting the details right instead of delivering a bunch of new additional features. Yeah, so what counts is that the software can perform really what the user needs. I think that's what software development is all about. And also to refer to the presentation of Tamara we just saw, I mean, the upcoming interface, the connection with Frilo and Allplan reinforcement design is very promising. I mean, this workflow is very manual at the moment in the structural engineering field.
How can the improved automated reinforcement have a positive impact on your daily work as a structural engineer?
Yeah, well, I've already spoken about Allplan being a really reliable, robust tool for us. I see in the version 2025, the Allplan team has really focused on the strengths for engineers, which is especially the rebar placement and the automation and interaction between structural analysis and BIM. I mean, these are all important steps in the right direction in making our work easier and more efficient.
All right. Thank you, Daniel, to have shared your opinion on the latest version of Allplan. I'm sure the improvements in Allplan 25 will provide the hope for productivity boost. Have a great day, and yeah, until next time.
Thanks, Tim. Bye-bye.
Daniel has just illustrated quite vividly that he especially expects the improvements in automatic reinforcement to increase efficiency. But what exactly do those improvements look like in the software? To dive into Allplan 2025 with you, I welcome now my colleague Christian Bierak. As product owner for Concrete Components, Christian contributes to delivering automated reinforcement workflows for structural engineers within Allplan. Before joining Allplan, Christian worked in a structural engineering office, preparing reinforcement detailing drawings and automating the design workflows. Christian, thanks for joining the event today. In your demo, you will focus on the most relevant improvements in automated reinforcement of walls and wall connections that have been implemented in Allplan 25. We heard already from Daniel how the enhancements of automated reinforcement will impact the daily work of structural engineers. What is your opinion on this? Why can structural engineers look forward to utilizing the improvements for their reinforcement drawings?
Welcome everyone. Hi team. My short answer is efficiency and reliability. When an engineer needs to reinforce hundreds of elements, automation helps them to eliminate the manual steps, allowing them to achieve more in less time. Since these functions utilize a parametric approach, the same end result will be created every single time, which of course raises the reliability of the work done.
That sounds really good. So I'm curious and I can't wait to get an idea of the enhanced functionalities in Allplan 2025. That's what you're here for, to show us what it looks like. So Christian, I hand over to you.
Welcome to my presentation, where I will show you the major improvements we have introduced to the automated wall and wall connection reinforcement functions in Allplan. In the first part, we will take a look at the opening reinforcement improvements. As you can see, we have added support for corner windows. we have also added support for a separate concrete cover value for openings. For every opening, it is now possible to create the vertical, horizontal, and diagonal reinforcement. The diameter of all positions can be set up separately, together with the extension length, which is calculated based on the selected standard in the options menu. If there are more than 4 bars selected per position, the option to edit the offset between the bars also becomes available. If one of the positions is not necessary, it can be simply disabled, as you can see with the diagonal bars. In this example, there is a niche from the outside of the wall cutting through the insulation layer, but only partially cuts into the concrete wall. The main reinforcement is adjusted to the opening, and the reinforcement at the inner surface of the niche can be set up separately, both in the horizontal and vertical direction. Both positions can be controlled with separate inputs for the diameter, spacing, and extension length. The extension length is also calculated automatically, just like in the previous example. The last feature of the opening reinforcement is the minimum opening dimension parameter. With this setting, it is possible to ignore openings under a certain size. Great for the openings which allow MEP systems to pass through walls and don't require as much reinforcing. For a wall-to-wall connection, the starter bars can be set up with hooks at their ends, which is a safety requirement in most countries. It is now also possible to add starter bars if the main reinforcement of a wall is created using meshes. These starter bars have their own controls. A new type of reinforcement can be set up at the top edge of the wall, which is part of the connection between the wall and the slab. Depending on the amount selected, it is possible to set the offset from the top and bottom of the slab. This enables the bars to be precisely placed. In this section, I will show the reinforcement setup options for the connection between walls and slabs depending on the modeling preferences of each user. In this example, the slab is modeled on top of the wall, but the slab can also be modeled next to the wall. If there is no slab present, then it can be turned off by selecting the first option. If the slab is modeled in between the walls, the slab thickness is recognized and calculated and the reinforcement adjusted. We can also see how the top edge reinforcement is set up. The only reinforcement to be added is the edge reinforcement of the connecting slab. In the last section, I will focus on the automated wall connection reinforcement improvements, which includes new bar geometries and more input options to shape the reinforcement to each detailing preference. Now the concrete cover at each surface can be controlled separately. Great if you have different fire resistance requirements or exposure classes at either side of the wall. This is possible to set up for both L and T-shaped wall connections. As was also shown previously, the position of the slab can be set up with the same controls, allowing the reinforcement to be adjusted accordingly. If the horizontal reinforcement is modeled using L-shaped bars, there is now an option to adjust the segment lengths according to the defined overlap length. This will create asymmetrical bars on the inner surface and a symmetrical bar on the outer surface. The other option will create symmetrical bars with the same geometry at all positions. The horizontal bar shape now can also be switched between U-shaped and L-shaped bars regardless of the connection angle between the walls. If you have an opening close to the wall connection, the stirrup creation can be turned on and set up independently from the rest of the horizontal reinforcement in the walls. In a non-90-degree connection, this will create a stirrup with a polygonal shape. Back to you, Tim.
Well, Christian, let me thank you for the short but still informative overview of the implementations to reinforce walls and wall connections more efficient. Before we move on to our next session, some customers might want to know why they should start adapting their workflows and what the future might bring. So, can you say a few words?
Sure. The automated reinforcement functions are developed by engineers for engineers. This means that we understand all the requirements and what we offer is really what they need. For the future, it is also in our plan to bring the cooperation of design engineers and rebar detailers closer with new workflows.
Thanks, Christian, once again for being part of our launch event and for this very promising outlook you gave to the end of the session. Take care and goodbye.
Goodbye.
Okay, Christian just gave us a very solid overview of the improvements within Allplan 2025 regarding automated reinforcement. In our next two sessions, we want to explore the topic reinforcement in more depth. Therefore, I'd like to welcome my next guest, Ciprian Poppa. Ciprian is the founder of Structural Class Design and was a beta tester for Allplan 2025. And he will share today with us his early experiences with the new version of Allplan. Welcome, Ciprian.
Hello, everyone. Thanks for having me today, Tim.
Hey, Ciprian. Great to have you with us today in Allplan's launch event. As a profound user of Allplan, we thought you would be a great fit for one of our sessions. So before we get going, can you tell us a bit more about yourself and your company, Structural Class Design?
I'm a structural engineer with a strong interest in research and software development. And the company Structural Class Design is helping Allplan and CI users to improve their usage of software by tailoring to their needs. So we help them develop their own parametric objects such as Python parts, Smart Parts, or visual scripting. And when it comes to SIA, we help them optimize their models, create parametric calculation models, and also develop their own custom checks using design forms technology.
As a structural engineer, you gained many years of experience in the AEC industry. So what makes you passionate about your profession?
We as engineers are naturally problem solvers, and having access to the cutting edge technology makes me feel really powerful in solving issues of traditional engineers. So I'm really passionate that I can use the future to solve the current challenges. And I really like to leverage technology in order to overcome the current problems like the loss of workforce and trying to do things smart to save time and money.
So as an AEC industry expert, you obviously must rely on the right software. So my question is, how long have you been Allplan using for now?
I've been using Allplan starting my third year as faculty. The faculty just was teaching us how to use 2D CAD software. I've seen one of the Allplan's presentation when I was student. I felt like this was the future. It was challenging journey initially because you had to build in 3D the model and then generate section views. But then I understood the advantages when it comes to making changes. So I was a visionary at that point, as most of the colleagues used 2D software. And ever since, I was involved in so many projects, especially having the opportunity to help customers do extraordinary projects. So if I start counting, there are about 14 years since I started using Allplan.
I assume, or I'm pretty certain, you have also been involved in many construction projects. What kind of projects are you using Allplan for?
Well, I'll just name two of my recent ones. The first one is Eroi Revoluții Square. It's a Calatrava-inspired canopy on top of a tram station, which is actually connecting the tram with the metro station. It was quite an innovative project for Romania at least, and BIM made this possible. So without having a good collaboration between architecture, structural engineering, calculation, execution, contractor, we wouldn't be able to do this within the time requested. And also the budget was very nicely estimated, and the project is already available for visiting in Romania. Just visit us at Eroi Square metro station and you'll see this modern marvel made of steel and glass. The second project I would like to talk about is Berceni Arena. It's a hockey stadium located also in Bucharest. It was a very challenging project due to the fact that the stadium was already under construction and the municipality wanted to change its face. So the theme from architect was a floating cloud, which allowed the audience to get inside. And Allplan and SIA, again, together, they made a great team and allow us to deliver this project as it was requested and as it looked in the architecture renderings. It's a marvel, and actually, this month in August, the first hockey match is going to be here. And as you see, during night, you can also project using the LED technology, different movies, and the actual match that's going inside the building.
These are two very impressive projects you realized. I especially like the combination of SIA Engineer and Allplan. So why do you prefer actually using Allplan?
Allplan is very friendly to any kind of interface, and it's both 2D, 3D at the same time, and also adding attributes, it becomes BIM. So it's one of the best BIM authoring tool. It's easy to grab everything, no matter the formats and what you get from the collaborators, and then you can send it to an analysis software such as SIA. So both have BIM certification, so the data is not lost. And what you do in the engineering part, in SIA Engineer, and make conclusion optimization, send back to Allplan. So Allplan is great for in all the processes, for initial planning to final execution drawing, and it's one of the best BIM authoring tools that I know.
And how about SIA Engineer? Why do you rely on that software to do your structural analysis and design?
SIA Engineer has been on the market for over 50 years. It's a very transparent software, and it has also many certification and integration. So it's BIM certified. It has one of the best Eurocode integration, and the end product of an engineering calculation is the engineering report that you get automatically in SIA. And this report helps you prove your work to any technical consultant or any checker, no matter if they heard of SIA or not already. But this transparent approach is what makes this solution trustworthy.
As I mentioned before in my introduction, you had the chance to be part of our best beta tester group for Allplan 2025. What is actually your favorite feature in the latest version of Allplan?
The favorite feature is the one that solves one of my pains, and that is the freeform reinforcement tool, which is now applicable to surfaces.
So how can the improved freeform reinforcement that we implemented in the new version have a positive impact on the daily work of structural engineers like you are?
Well, before this function, I thought Allplan was the only solution in the world to 3D reinforce anything, any complex infrastructure challenge. Due to the fact of many innovation like sweep bars and different interpolation of linear sections. But there were some points where I had to manually do the bars, and that was tunnel intersections or when we had to do a ramps. And that made me feel like I wasn't using everything efficiently. So now with Allplan 2024, with this new surface reinforcement tool, it looks like you are just doing one click and you decide the spacing and rebar diameter, and it simply does the reinforcement. And this helps a lot because you can easily make some estimation during tendering phase of a project, but then also you can easily change because it's parametric in other in construction stages of the software. So the fact that you don't have to manually linear interpolate on small areas, but instead you just click even on a curved surface and impose the reinforcement at a certain step and diameter, for me, it's very impressive.
All right. Happy to have developed something that impresses you. Thank you, Ciprian, for sharing your experiences with the new version of Allplan 2025. It was a pleasure to welcome you as my guest today. May Allplan 2025 support you and all the other structural engineers out there in continuing to plan and realize such demanding and impressive construction projects as the two you showed us today.
Thanks, Im, for having me.
We just heard from Ciprian how much he loves the progress regarding freeform reinforcement that has been made in Allplan 2025. But how do you make use of the improvements in freeform reinforcement in the software? To answer that question, I now bring in my colleague Burkhard Rützel. Burkhard is a graduated civil engineer, and during his studies at the Technical University of Munich, he already gained extensive experience in software programming. In 1988, he started at Allplan with the development of 3D reinforcement and later transferred to the product management team, where he currently works as a product manager engineering, and of course is still intensively involved in the reinforcement detailing software development. As already mentioned, Burkhard, you are going to demonstrate in your session how modern high-performance modeling of free-form reinforcement can be performed in Allplan 2025. Let me ask you, before we get started, how does the new tool contribute to a more efficient free-form reinforcement?
Yeah, hello everyone. Hello Tim. The new freeform reinforcement is very quick and very easy to use because we calculate the bar shapes and the placements in both directions in one step. And this you can do in isometric view. Just simple click a surface and the reinforcement is done.
Yeah, your slogan, I remember, is select a surface and done. I think that slogan is music to the ears of Allplan users, and I'm excited to see how powerful the new feature really is. So Burkhard, the floor is yours.
Yeah, so as Tim and Ciprian already mentioned, the main topic in Allplan 2025 for reinforcement detailer is a new Allplan freeform reinforcement. For this, we implemented the new tool Place Bars Along Surface. I prepared 4 different examples. I start with a simple slab with plain surfaces, and my last example is a tunnel, a complex structure with a main tunnel and a service tunnel. Let's start with the first example, the simple slab. Here I like to use the already existing freeform reinforcement, extrude bars along path, and to show how well this works together with the new freeform reinforcement. Here with the new freeform reinforcement, I select the surface and the reinforcement is done. Of course, you can change the reinforcement afterwards. And if you like to do even more modification, you can unlink the reinforcement and then you can do every modification in Allplan you know from previous Allplan version. For example, change here in one part the distance or number of pieces. My second example is a circular wall. And here again, I use the already existing freeform reinforcement to show how well this works together. So I select the path and the reinforcement is done. Or I select a surface and the reinforcement is done. So I select here the outer and the inner surface and the reinforcement is a circular wall is finished. My third example is a ramp. A ramp was mentioned also by Ciprian. And here, this ramp can be the entrance of a, let's say, parking garage. And here it's really easy to use. As you see, I select the surface and reinforcement is done. It's really a pleasure to use this new tool. So also in the last example, you can see how easy it is. Now you know already the procedure, so we can enjoy how easy it is to create here the reinforcement in the service tunnel, which is crossed by a main tunnel. 4 clicks and the main reinforcement in the service tunnel is done. And of course, in the main tunnel, we need a little bit more reinforcement. And 2 clicks later, also the reinforcement in the main tunnel is created. I like to compare here a little bit the already existing freeform reinforcement with the new freeform reinforcement. So extrude bars along path, which I used in my previous example, and sweep bars along path. These both are more shape oriented for longer components like beams or bridges. And you have to work with sections and paths, of course. Place bars along surface is surface oriented for large surfaces, and we create the reinforcement along the U and V curves. This new tool, this new freeform reinforcement is our answer to the trend to more and more organic shapes in buildings and infrastructure components. Back to you, Tim.
Well, thank you, Burkhard. You left me impressed by the ease and speed users can create freeform reinforcement, especially for complex structures. Before you leave us, are there any other improvements for reinforcement detailers you would like to mention?
I like to mention the new possibilities in direct object modification too, because this is also very easy to use. Select an object and do the direct object modification immediately in the graphic area, and we have now this possibility for circular reinforcement and place in rotation. And on top, you can now do some modification which were not possible in the past. For example, in place and rotation, you can change the circle, which was not possible in the previous Alplan version.
Sounds good. Sounds really good. So thanks again for giving us a glimpse of the enhanced possibility to place bars along any surface. I'm certain our customers will value the feature as much as Ciprian. So take care and see you soon, Burkhard.
Yeah, thanks a lot, Tim. Thanks a lot to everyone. I was very proud to present here the development of our reinforcement detailing developer in the last year. Ciao.